Okay, so now this section is all about operations with functions. So we first start by talking how do you find the domain and the range. So in this case, this is a domain for different types of functions. So if we break it into four different cases. The first one says, does the function have a denominator? If so, the domain is going to be the places where the denominator is non-zero. And in case two, it says, does the function have a square root? If the stuff under the square root, or if there's a square root, then the stuff under the square root must be greater than or equal to zero. No, case three says, does the function have a square root in the denominator? If so, the stuff under the square root must be positive. So it must be strictly positive because we can't divide by zero, right? And the last case says, if the function has no denominator and no square root, then the domain is all real numbers. So I'm going to go ahead and we'll start looking at a couple of examples of each of these. So it literally goes case by case. So let's go over this first one here. Let's see, what color am I using? I have no idea. We'll see in a second. So it says find the domain of f of x. So here, notice that the function has a denominator. Namely, it's 3x plus 15. So all I want to do is first set that equal to 0 and solve. So if I do that, 3x plus 15 equals 0. First step is to subtract 15 from both sides. Then I have 3x equals 15, right? And that implies that x is what? Someone say in the comments or speak it out. I don't care. Yeah, x is 5, right? So 5 is the only place where we actually have the denominator being 0. So that means we need to exclude 5 from the domain, and we're going to do that this way. So there's a couple ways you could write it. If I want to write this in interval notation, then the domain consists of negative infinity up to, oh, this should be a minus 15 here, my bad. So this should be a minus 5. Let me go back and erase that real quick. It's like I know I'm missing something up right here. It should be a negative. So this should be 3x equals minus 15, right? And this means x equals negative 5. So we're going to exclude the point negative 5 from the domain. So we do that by this, negative infinity up to negative 5. And then remember when we had those absolute values where we had the function, the two domains don't overlap at all. Whenever we broke it up into each piece, we use that union symbol. We again use the union symbol here. So all we're doing here is excluding the point negative 5 from the domain. That's all we're doing. Another way you could say this is just the set of x and r. So this just means the real numbers that x is a real number where x is not equal to negative 5. So the one I like to use is the top one. But the domain is just the places we have excluding negative 5, right? Everyone okay with how that one is? That one's simple. Just set the denominator equal to 0 and then exclude the point where it equals 0. Now, this next one here is just a square root. And it's in the denominator. It's in the numerator. There is no denominator. So the stuff must be just greater than or equal to 0. So that means I need to set 2x minus 8 greater than or equal to 0 and solve. So the first step is to add 8 to both sides, and you get 2x is greater than or equal to 8. And that implies x is greater than or equal to what? Yeah, 4, right? And can anyone explain why the sign of the inequality did not change there? So it has to do with the fact that you divided by a positive number, right? And remember, when you divide by a positive number, it does not change the sign of the inequality. So here, then the domain, if we want to write it in interval notation like we usually do. So it includes the 0.4 and everything greater than that. So it's going to be bracket 4, comma, infinity. Everyone okay with that one there? All you're doing on that one is first making it an inequality where you have the stuff underneath the inequality is greater than or equal to 0, and then solving. Now the next one here is an example where we have the square root in the denominator. So what we need is this square root stuff underneath it to be greater than 0, strictly greater than 0. So this means that x minus 4 must be strictly greater than 0. And this one's really easy. You just add 4 to both sides and you get x is greater than 4. So the domain is similar to the one before. So the domain here, oops, why did I put b? Let's do this. The domain is from 4 to infinity, but with a parentheses around the 4. Right? Everyone okay with that one? And the last case on here is what is the domain of this? Since here it fits into case 4, where the function has no denominator and square root. It only has powers of x and a constant. So, since no denominators and no square roots, this implies the domain is just all real numbers. Or if we want to write that in interval notation, i.e. it's minus infinity to infinity. And sometimes you can graph these and tell what the domain is. Sometimes it's easier to look at the graph than actually just analyzing the function, but sometimes it's not because the asymptotes or stuff like that we're going to get to later are kind of harder to find if you don't find them by using a formula. Everyone okay with that page there? They just went through case by case, each of those. So this next thing here we refer to as functional evaluation, and we'll talk about how to find a difference quotient later on the next page, I'm pretty sure. Let's see. Does it? No, it doesn't. All right, there it is. So all we're doing here is just plugging in numbers to the function. So here, how do we find f of minus 1? All you do is plug in minus 1. So let's do this. F of minus 1 is 2 times minus 1 minus 5 divided by 7 times minus 1 plus 8. In the numerator, this becomes minus 7. In the denominator, this becomes 1. So if I simplify that, it's minus 7. That one's pretty simple. Just plug and chuck. That's all it wants there. Now the next part says find f of minus x. So this is kind of like how when we tested if a function was odd or even, we plugged in minus x and saw what we got. So let's just plug in minus x here. So f of minus x is equal to 2 times minus x minus 5 divided by 7 times minus x plus 8. And if I simplify that, that's minus 2x minus 5 divided by negative 7x plus 8. So based off of that, do you think that this function is odd, even, or neither? It's not on here, but what do you think? It looks like it's actually neither. And you can see in the next one, whenever we calculate negative f of x, right? So let's calculate negative f of x and see what we get. Because remember, a function is odd if we had f of x, or f of minus x, is equal to minus f of x. That's when we had an odd function, right? So let's see what happens in the next one. This is minus f of x, is what we're going to calculate now. So minus f of x is, all I'm doing is putting a minus up top. So this would be minus 2x minus 5 divided by 7x plus 8. If I do that in the numerator, this becomes minus 2x plus 5. In the denominator, this becomes 7x plus 8. And are these two equal? Are those two equal? What do you think? Anyone have any ideas? So in that case, no, they're not equal. So the function is actually neither odd nor even. So now let's go on to calculating f of x plus h. So what this does is instead of plugging in x, it plugs in x plus h. So let's see how this would work. So f of x plus h, oops, is, so up here, any place I see an x, I'm going to plug in an x plus h. So this would be 2 times x plus h minus 5 divided by 7 times x plus h plus 8. So I distribute the 2 up in the top, so this would be 2x plus 2h minus 5. And the denominators become 7x plus 7h plus 8. Everyone okay with what I did there? All I did was instead of plugging in x for up here, I plugged in x plus h. And then I just used the distributive property. Everyone okay with that functional evaluation there? The first part, all we did was actually plug in a whole number. We plugged in -1. Then we plugged in, just plug a minus x in instead of positive x. Then to determine if it's odd or even, we plugged in a minus f of x, or just threw a minus out front of it, and saw if it matched f of minus x, and in this case it didn't. And obviously it doesn't match f of x, so it's neither odd nor even. And then the last part, this is kind of preparing you for in a couple pages when we talk about a difference quotient, because we're going to look at what happens when I plug in f of x plus h and subtract off the original f of x function. I'm left with something, and then I divide that by h. And that'll be called the difference quotient. And we'll get to that in the last page, I'm pretty sure, or one before the last page. So the next thing we want to look at is functional addition and subtraction. So this is pretty simple stuff. So it starts off by doing it easier. So it says, what's f plus g evaluated at 1, and what's the domain? So what I like to do is I'm actually going to start with what's f plus g of x. And then I can just plug in 1, and that'll be the top part. So let's try this. What is f plus g of x? So it is actually well known that when I take f plus g of x, this is actually just f of x plus g of x. So if I do that, f of x is 5 over x plus 2. And then we have plus negative 7x over, again, x plus 2. But here we have an x plus 2 that's common in the denominator, so I can just add the numerators. So this becomes 5 minus 7x divided by x plus 2. So that's what f plus g of x is. Now, if I want to find the domain, this fits into what case? 1, 2, 3, or 4 from up top? What do you think? Which one does it fit into? Any guesses on which case it fits into? 1, 2, 3, or 4? Colin, you're right. It fits into case 1. Does the function have a denominator? If so, the denominator must not equal 0. So if I want to evaluate when does this equal 0, all I'm going to do is say, what's the denominator? So the denominator is x plus 2. And x plus 2 equals 0 when x equals minus 2, right? So what I want to do is just exclude that point minus 2 from the domain of the function. So then my new domain, excluding that point, becomes this. Minus infinity up to minus 2 union minus 2 to infinity. So be careful when you're writing these. So whenever you're having to exclude that endpoint, then we're going to have to put parentheses around those. So now I know the functional form of f plus g of x. Now let's just plug in 1. So if I do that, this is just 5 minus 7 times 1 over 1 plus 2, right? And if I do the numerator, that's 5 minus 7, or minus 2. And the denominator is 1 plus 2, or 3. So f plus g of 1 is just minus 2/3. So let's do the same thing on this one here. I want to first find out what's g minus f of x, and then I'm going to find the domain of that. And then I'm just going to plug in 1 to f minus g, or g minus f. So just like here, how f plus g of x was just f of x plus g of x, g minus f of x is just g of x minus f of x. So what was g originally? It was minus 7x over x plus 2. And what was f? It was 5 divided by x plus 2. And again, we still have that common denominator of x plus 2, so we can just add, or in this case, subtract the numerators. So this becomes minus 7x minus 5 over x plus 2. Now let's go for the domain. Do you think it has the same domain as the first one or not? So it's a trick question. It actually does. So, and why? Because the denominator is still the same. We still have the same denominator of x plus 2. And when does that equal 0? Still when x equals minus 2. So the domain is still the same from this previous part. So the domain is still negative infinity up to negative 2 and negative 2 to infinity with a union in between. Everyone okay with that? So now to find g minus f of 1, all I'm going to do is plug in 1 to this expression right here at the bottom. So if I do this, we want to do minus 7 times 1 minus 5 divided by 1 plus 2. And if I do that, in the numerator, I get minus 7 minus 5, which ends up being minus 12. And then I divide that by 3, and I get minus 4. So minus 12 over 3 is minus 4. Everyone okay with that one? Okay. So now we talked about how do we add and how do we subtract functions. So remember the addition, f plus g of x is just f of x plus g of x. And when I'm doing the subtraction, g minus f of x, it's just g of x minus f of x. Now we're going to expand this to what happens when we multiply and divide functions. Do they behave like we think they would? And they do. So let's look at this first part. I'm going to do it how I've been doing these two. I'm going to do it in general. So I'm going to do f times g, and then I'll do the example. So if I'm doing f times g of x, this is just f of x times g of x. So f of x was 4x plus 5. And I'm multiplying that by the square root of x. So now, this one is where it gets a little weird if you haven't seen something like this before. So the square root of x can also be written as x to a power. So if I write the square root of x, this can also be written as x to the 1/2 power. And then if I have something like x to the a times x to the b, this is just x to the a plus b. And that's what happens here. We have 4x, and we're multiplying it by the square root of x. So let's write out what this is over here. So this is 4x times, in this case, x to the 1/2, because we have the square root of x. And here, I use this rule of x to the a times x to the b is x to the a plus b. So here, this constant 4 just stays outside. And I'm left with 1 plus 1/2, or x to the 3/2, right? So the first term in here is 4x to the 3/2. And then we have plus 5 square root of x. Everyone okay with that work so far? Just for the multiplication piece, not for the domain, but just for the multiplying the two functions. Does that make sense so far? Okay. So now let's find the domain. So in this case here, both of these actually involve a square root. So if I want to write out what this looks like, let's write it out, expanding it like this. This is actually equal to 4, and then we have the square root of x to the third plus 5 square root of x. That's actually what the function looks like. And that uses this right here, this piece, uses the fact that x to the a over b is equal to the bth root of x to the a. In this case, a is 3 and b is 2, so we're just taking the square root, the common square root of x to the third. So notice that here we have a square root in both of these terms. So we have the domain must be greater than 0, right? So we need x greater than or equal to 0 for this function to be defined, which implies that the domain is from 0 to infinity, including 0. And it includes 0 because it's in the numerator. There's no denominator. So it fits where we can include at that point 0. Now let's do f times g evaluated at 4. So if I do this, this is just 4 times the cubed root of 4 to the third, or the square root of 4 to the third, and then plus 5 times the square root of 4. So 4 to the third power is 64. So this is 4 times the square root of 64 plus 5 times the square root of 4, which is just 2. So when I do 5 times 2, this becomes 10. But 4 times the square root of 64 is just 4 times 8, or 32. So this is 32 plus 10, or 42. So that's what happened when we multiplied the two functions together. Now let's see what happens when we divide. So again, I'm going to start out with the in general formula, then I'm going to work to the specific example that we're looking at, plugging in a number. So we know that it's going to behave just like we think. G divided by f of x is just g of x divided by f of x. So what was g of x? It's the square root of x. And what was f of x? 4x plus 5. Now, that is the simplest it can get. But this one is kind of a trick because you'll figure out in a second. So here, let's first set the denominator equal to 0 and solve. If I do that, 4x plus 5 equaling 0. I subtract 5 from both sides. I get 4x equals minus 5. I divide both sides by 4 to get x is minus 5/4. So for the bottom piece to work, we need anything except negative 5/2, right? But we also need the square root of x in the numerator to be defined, and that's only defined for positive numbers, right? It's only for anything greater than 0. So we need x greater than or equal to 0 for the numerator to be defined as well. So this implies that the domain is 0 to infinity, including 0. And then again, doing the example portion where we just plug in a number, this would be the square root of 4 divided by 4 times 4 plus 5. And this just ends up being square root of 4 is 2. 4 times 4 is 16. 16 plus 5 is 21. All right. Everyone okay with that? That one was a little tricky. The easiest way to determine the domain on this one would be to graph it in Desmos and see where does the function actually start at what x value. And then you can figure it out. Now this next one here is where people usually struggle. So it says use the graphs to find the domain of f plus g. So what we need to do is figure out where f and g both defined. So f of x goes from -2 to 5. G of x goes from -5 to 7. So what pieces do they have in common? So here is where they begin, both begin, and here is where I have they both end. I'm looking at what piece do they overlap on. So if I'm looking at that, the domain is this piece here from -2. Sorry, let me erase that. That's bad. From -2 to 5. Everyone okay with that? It's where those two pieces or the two functions overlap. They overlap on the interval from -2 to 5. Because here, if you look from -5 to -3 to -2, f of x is not defined. So f plus g won't make sense. And here again, whenever I'm looking at x is 6 here, g of x will work, but f of x is not defined, so f plus g won't make sense again. It'll be undefined. Now, the next thing we want to do here is find out how do we evaluate this? So it says find f plus g of 2. So if I go here, here's when x is 2. So f plus g of 2 is just like how we did earlier. It's f of 2 plus g of 2, right? And then you can read these numbers off of the graph. If I look at f of 2, it's down here, right here. That's -1. If I look at g of 2, it's up here, and it's 4. So this is just -1 plus 4 or 3. Is everyone okay with that so far? Okay, now what I'm going to show you here is how you would graph the f plus g, the entire thing. So I'm going to go to another color, put orange. So let's do this. What we're going to do is look at the piece where both of these are defined, and we're going to do f plus g at each of those numbers. So that means I'm going to do what's f of x plus g of x from -2 all the way up until -5. So if I do that, here, f plus g would be 2 plus 3, or 5. So here's the first point of f plus g. Then the next point, when I plug in my x is -1, I have 4 plus 1, or 5 again. So it's constant so far. Now here, I have 0 plus 5 again when x is 0. So far, it's just a constant at 5. But here again, what do we have? 0 plus 5, still a constant at 5 again. Now is where it changes. Here, when we get to x is 2, g of x is 4, f of x is -1. So when I take 4 and I subtract off 1 from that, I'm at 3. So that's when it starts to go down. And now let's look at when x is 3. When x is 3, f is -2, and g is still +4. So when I take -2 and I add 4, that's +2. When I get to x is 4, f of x is -4, g of x is 4, so -4 plus 4 is 0. And then the last piece of the domain, we have 5. F of x is -6, g of x is 3, so -6 plus 3 is -3. And that's how you'd find f plus g. So what you do, if I write it out like this, is it's f of x plus g of x on the interval -2 to 5. So it's just using the restricted domain for f plus g and adding each of the outputs for these. Just like here, how we did f2 plus g of 2, we're doing it for every value of x in between -2 and 5. And the last thing we're going to cover here is the difference quotient. So what I want to do is plug in, let's first find f of x plus h. So if I do that, f of x plus h is just 2 times x plus h plus 3, which is just 2x plus 2h plus 3. And now I want to subtract off from this f of x. So if I do f of x plus h minus f of x, this is 2x plus 2h plus 3 minus 2x plus 3. So here, look, 2x minus 2x, those goes away. And then 3 minus 3, those go away. And I'm just left with 2h. So now I know what this numerator is so far for this one. It's just 2h. So then f of x plus h minus f of x over h is just 2h over h, or 2, because these h's go away, right? Everyone okay with that? So now I'm going to go over this last one here, and then I'll leave y'all with the class activity, and we'll complete or go back over that on Tuesday. So let's start again here with f of x plus h. So f of x plus h is x plus h squared minus x plus 1. If I simplify this, this is x squared minus 2x h plus h squared plus, this should be x plus h right here. So this would be x plus h plus 1. So minus x plus h plus 1. So this would be, so we got the 2x. So here are x squared plus 2xh plus h squared minus x minus h plus 1. And then next we're going to do f of x. So we're going to do f of x plus h minus f of x. So this is x squared plus 2x h plus h squared minus x minus h plus 1 minus x squared minus x plus 1. Now we got some simplifying to do. The x squared minus x squared, that goes away. The minus x and the minus minus x goes away. So this is minus x and then plus x, that goes away. And also the 1 goes away. I'm left with 1 minus 1. So this ends up being 2x h plus h squared minus h. And now if I want to divide that by h to get the difference quotient, this is f of x plus h minus f of x over h. Then this would be 2xh plus h squared minus h divided by h. So this simplifies to 2xh over h is 2x. H squared over h is just h. And then minus h over h is minus 1. So that's the final difference quotient there. So I know I went through those a little quick, but all we're doing is going step by step. First, find f of x plus h. Then subtract off the original f of x function. Stuff will cancel. And you're left with stuff that's just in terms of h, usually, and x, whenever you get to this second step of x, f of x plus h minus f of x. And then we divide by h. And this is where we actually start some calculus stuff up. We're not going to cover it in this course. This is actually how you find the derivative. This is the formula that goes inside of a limit. And you'll talk about that when you get to Calc 1. But what I want for y'all to finish up and bring to class on Tuesday is this class activity here. It's not anything too hard. It's just plugging in some numbers. I guess we can just do it right now. It only takes a minute. And then we can start the next section next time. So this first one says the domain of this is all real numbers except when x is what? So here, just set the denominator equal to 0 and solve. X minus 5 equals 0. Implies x is 5. So that means it's the, sorry, trying to rewrite that. All real numbers except when x is 5, right? And then here for the next one, all we do is plug in minus 2, or minus 3. So if I do that, the square root of minus 3 minus 2 plus 1. So minus 3 minus 2 is minus 5. And when I take the absolute value of that, it's 5. And I'm left with 5 plus 1, or 6. And that's where we'll stop for today. I'll go ahead and post the Zoom recording later today on Moodle as well. But next time we will pick up and we will start with section 2.4. We'll start back in class on Tuesday as long as weather permits, which it should. All right, I'll see y'all on Tuesday. Y'all have a good day.